So we look at question number 4 here. Our function also given here is a piecewise function. So first, find the limit 3 approaches 3 from the left hand side and limit 3 approaches from the right hand side. So first of all, we can see we have a modulus function here. So our modulus function need to be defined in piecewise function so that we can select our interval by the corresponding function correctly. So our first step will be we express our piecewise function, our modulus x minus 3 into piecewise function. So the first piece will be positive when it is greater equals to 0. And then another piece will be negative for this domain less than 0. Then we simplify our function here. It will be x greater equals to 3 and negative x plus 3 for x less than 3. So we can see our interval here. We draw our interval so that we can clearly see our function. For less than 3, our rational function is this. So at the part of denominator where the piecewise function exists, we need to select a correct region. So for x less than 3, the function selected here will be this, because interval x less than 3. So our denominator part, our modulus part, should be using the function of negative x plus 3. So exactly on the 3 value here, it is a point A, and then 3 to 4 is 2x minus b, and then more than 4 is c. So this is our information given from our questions. Then we can start doing our limit. So for question A, when we want to find our limit for x approaches 3 from the left hand side, select a correct function. So our function will be here, the rational function, quadratic over negative x plus 3. So we try to attempt to solve our limit by substitute the x equals to 3. You will notice that it is a 0 over 0 situation. It is an IDF situation. So when you have IDF situation, for polynomial case, we can factorize our polynomial quadratic here. So I take out the negative and the quadratic we factorize. So you can notice that we can simplify our function. So we already simplify our situation of IDF. So now we attempt to solve our limit again by substitute the value of 3 inside. So it will be 3 plus 4 over negative 1. So it gives us negative 7. So that will be our limit from left hand side. Then we continue for the next question. Limit approaches 3 from the right hand side. For the functions, you can see this is our x equals to 3. From the right hand side, our function is 2x minus b. Then we try to substitute our x equals to 3 inside here. It will give us 6 minus b. So that will be our answer in terms of b. So from here, what is important is the first part will be expressing our modulus function into piecewise functions. So that will be our basic come from topic 5. And then when we solving our limit, which consists of IDF, we have to factorize it and simplify to the answer. So this is the limit from the right hand side. Select the correct function and simplify to the answer. So that will be our part A. We continue to part B. So what's the question here is they ask us use the definition of continuity, means the 3 conditions to determine the value of a and b if the function is continuous at x equals to 3. So they're continuous at here. So by the condition of the continuity, the first condition is the point f3. So what is the point? So we look at our interval here. When x equals to 3, our function is equals to a. Our point is equals to a. So it is defined, but we just don't know what is the value of a only, so the condition is defined. Then number 2, the limit must be exists. So we look at limit when x approaches 3 of the function. We can see our limit left hand side, it is value of -7, limit right hand side is 6 minus b. So the limit for this function, it must be exists. When it is exists means their limit from left hand side should be equals to the limit approaches 3 from the right hand side. So -7 should be equals to 6 minus b. So this is our condition. So find out our b here, we simplify our b here. Our b here will equals to 13. So this is how we find out our a and b. They said if our function is continuous, so means our function definitely will continuous. So our function definitely will fulfill that 3 condition. So condition number 3 is in continuity is the point f3 must be equals to the limit. So we found our f3 already, our point is equals to a. Meanwhile, our limit is exists, so you can see limit exists, it is equals to -7. So we get our constant a is equals to -7. So therefore, our concept here is the first one, our point f3 is equals to a. There will be our basic. Then by using the condition number 2, limit must be exists, means the answer for limit approaches left hand side equals to right hand side to find out our constant b. And then this is our concept of condition number 3 to find out our a. We continue for question C. The question C, they ask for what value of C to make sure this function discontinuous. So when we have continuous, we must fulfill 3 conditions. But once we want to make the function discontinuous, we will challenge one of the conditions. So we will make one of the conditions fail, then automatically the function will be discontinuous. So the most easier part, we will make the function discontinuous as x equals to 4 is we make sure the limit does not exist. We make sure the limit from left hand side does not same with the limit from the right hand side. Once its condition 2 is failed, then automatic the function is discontinuous. So we will start doing limit to make it discontinuous. Limit x approaches 4. From the left hand side, we select our function here. 4 from the left hand side is 2x minus b. So it is 2x minus b. Our b is 13. We make sure it does not same with the limit approaches x approaches 4 from the right hand side. So we look at x equals to 4 here. Right hand side is value c. Our function here is value c. So we attempt solving our limit. Substitute x equals to 4 here. It will be 8 minus 13. It will -5. So limit to a constant is c. So as long as c is not equals to -5, the function will discontinuous. So our answer will be c not equals to -5, or we can accept c can be any real number except -5. Means once we put -5, it will continuous. We didn't put -5 not equals to -5, it will discontinuous because we make it not equal. Not equals means this is a situation discontinuous. So discontinuous, this c not equals to -5, it will make the function discontinuous. Okay, so our concept here will be limit left hand side not equals to right hand side in order to find out the value. So of course, we also can write the answer like this. C is all the real number except for -5. C is an element or element of real number except, So this is a slope, means except for -5, means C cannot be -5.